Hey guys, welcome back to AlgoYogi. We are doing linked list series, and our next problem in the list is reverse linked list second. Let's go to the problem on LeetCode. So given the head of a singly linked list and two integers left and right, where left is less than or equal to right, reverse the nodes of the list from position left to position right. And so left and right, the integers represent the position of the nodes from the beginning to the end. So basically in the first example, given that left is 2, right is 4, so it's 2 and 4, and basically the nth node left is 2, so 1 and 2, and then this is 4, and they've been just reversed in the result list. So let's see how we're going to approach it. So basically this is my left and this is my right, and if you see, this part of the list has been reversed. 4 came over here, 2 is over here, 3 remains over there, and this is what we need to return. Now there are a couple of ways we can do it. First is basically the brute force approach. Take the list, convert it into an array, 4 and 5, and then take this, reverse it, basically take this half of the array and reverse it. This is how you reverse this, and then this will become basically like this, and then you just convert it into a linked list and then return the head. But that's not how we're going to do it. We're going to play around with the pointers. So how do we do it? First thing is reaching these left and right pointers so that we can reverse. We know how to reverse a linked list. That's the first problem in the linked list that we have solved. So we know it. Now, how about we basically start at the head and then try to find the left node. So basically the left position of in the linked list. So this is my left, and then what I'll do is I will start reversing right from here. So basically not actually from here, but one node before it. Even if I start reversing here, that will still be a reversed list. So I'm going to start reversing over here, but I will keep a pointer to this thing. I can call it let's say left previous, because it's previous to the left pointer. This is the left pointer. So I'm going to start basically reversing the list starting at my left pointer. So as you can see, this is where I am, and I'm going to start reversing it. So you know how do we reverse it. We're going to make a pointer called prev. That's going to be none, so it's prev, and I'm going to basically make it point to prev, and then I will move this next and move my previous to the current. I'll call it current when I'm dealing with it. So what I'll do is basically this goes ahead, and this is my current now, and this is my prev. Then I'm gonna basically point this to my prev, save this as next pointer, and move my prev here, move my current over here. So I know it's kind of messy, but you know what I'm trying to do. I'm just basically iterating the reverse linked list approach just over this section. And once I basically reach the right position, and that would be basically if I'm starting over here and I'm given left as 2 and right as 4, then I know the number of nodes that I'm going to traverse between this is basically 2 plus 1, 3 nodes I'm going to traverse, so that I end up basically my current pointer ends up at 5, and then I will end up in a situation where I will have these pointers over here. So let me just show you what the situation will be. So the situation would be, this is my left previous, and these are all reversed. This is reversed, this is pointing to some none node, and this is reversed, and this is where my current is, and this is where my previous is. That's the situation I will end up with if I start basically reversing the linked list at my left position and until I reach my right position, basically this. So now what I'll do, I'll take this left previous, and since in reversed linked list it needs to point to 4, it needs to point to 4, so this is currently it's pointing over here, but I know that 2 right now needs to point to 5, right? So, and I do my one's pointer is still pointing its next pointer to 2, and 2 is what needs to point to 5. So what I'll do is point left prev dot next is 2, 2's next, I will point it to basically cur. So this is the current right here, so this will basically 2 will point to 5, this will get set. Now the remaining thing is 4 is basically need to be pointed from 1 now. So this left prev dot next would point to prev, and I know this was the critical point which was holding to the beginning and to the end of the list, because we started iterating over here, then we needed this reference to point it to the end because it will become reversed, and then still we needed to point the end of our list, basically the list that we needed to reverse, the end of that, so that will become the beginning. So that's what is this doing, basically left prev dot next equals to prev now. Okay, handwriting really trash, but I guess you guys got the logic, so I'm not gonna do anything with it, but let's get into the coding part. All right, so as I said, let's have a reference to the head so that in the end we return it. So we create a dummy node, and we're gonna call it list node, give it any value, I'll give it 0, and its next pointer would be head. Then I will have something called left prev and cur. So left prev would be pointing to basically dummy because it's the previous node, and it's pointing to head, so it's basically this will iterate over our list itself. It's given that left prev remains, if I zoom out here I'll show you. So left prev currently pointing to the dummy somewhere, and then once I reach my left node, which is 2, this left prev would be pointing at 1, and as we can see, we have seen it in the explanation that this is a key node basically, which needs to be used to access 2 and to basically point in the end to 4, so that 1 points to 4, and once we have this access, its next points to 5. So that's what we're gonna do now. So left prev is pointing to dummy, and then my current is pointing to head. I can point it to dummy.next, which is the same thing. If you can do that, if that helps you understand this better. So okay, let's reach to the left position, which would be basically we can use a for loop in range left -1. I'm gonna do. Why? Because currently I'm pointing, my current is pointing to the head, so moving 1 position means I'm still there. So I have to, if I needed to make one move towards right, basically, then I didn't have to do anything. But if I want to move to 2, then I have to make 1 move, not 2 moves. Okay, otherwise I'll be at the 3rd position. So what I would do is I'll move my cur equals to cur.next, and we also need to move our left prev. All right, so left prev.next would become not that next, left prev.next. All right, Then now we are at a position where my current is pointing to left and left prev is pointing to the previous one. Now is the part where I start reversing. Reversing is quite really easy. We have done it so many times. So prev will point to none. Current, we know current is pointing to the start of the left, and that's where we're gonna start. It's reversing the list. So I'm gonna start a for loop, and this time it's gonna be as we talked about. So it will be right minus left plus 1, because I wanna end up my current pointing to the next pointer of the right. All right, so that's why I'm gonna add 1. So what I'm gonna do right now is I'm gonna save the next pointer to basically cur.next, so that I have reference, because now current needs to point. So cur.next needs to point to prev, and basically prev needs to become current, and that was because current will now point to next. All right, once we come out of this loop, we will be you can see in the first example, once we come out of this loop, current was pointing to 2. We keep moving forward, keep reversing these pointers. Now 2 is basically pointing to none, 2 is pointing to none, 3 is pointing to 2, 4 is pointing to 3, 4 is where my prev is, and 5 is where my current is. So what I want to do is, since I had left prev, which was the previous node of current when it started at left, so this is 1 right now. So its next is 2, and 2 now needs to point to 5. Dot next needs to point to 5. 5 is what? Cur. All right, and then my previous, which is this, now pointing to 4. So prev dot next needs to point to, so this is basically my previous right now, and it needs to point to 3. Wait, no, I don't think that's what I meant. What is my previous pointing to? My previous is pointing here. Okay, no, that's not what I meant. What I meant to do is my 1 need to point to prev, not my prev needs to point to 1. So prev, this will still be left prev. I have to reuse it. Sorry about that. So I have to reuse it. I can zoom in so that the code becomes easy to be seen. So now it needs to point to 4, which is my prev. Okay. All right, then what do? I think that's it. We're gonna now return dummy.next. All right, dummy.next. Let me zoom out now. I think we did everything correct. Let's run it on example. Awesome, and let's submit it. Cool, 100%. Honestly, is this the most efficient solution? Could be. Let's write the time complexity, and that is big of n. That is the length, because at the end of the day we are just traversing at least until right, you know. So worst case it would be the right is the last position, so we will traverse the all given n nodes. Now let's write the space complexity. Did we use any space? I don't think we did, so it's gonna be 1. Did we use any space? I don't think we did not. It was just, we were just playing around with the pointers. So let's go back to AlgoYogi, mark this solved, and see you guys in the next problem. Until then, bye-bye.